get back to where we need to be. And we are recording again. So if you remember from basic graphing, probably in middle school, you learned that the quadrants in your coordinate plane have 4 pieces. Quadrant 1, quadrant 2, these are counterclockwise, quadrant 3 and quadrant 4. And basically we start counting from the origin. You remember that? And we have ordered pairs that are x, y. The x tells us to go right or left. Right if it's positive, left if it's negative. And the y tells us to go up or down. Up if it's positive, down if it's negative. Okay? So we have a set of first coordinates and a set of second coordinates. These are also known as the domain and the range. The domain is all of the things that x is allowed to be. All of the places where x is defined. Okay? X is defined as we've talked about that section that we just finished. There are places where x cannot exist because we get an undefined output. So that's kind of what this is about. Okay, domain and range. The range is what y is. So this is the set of inputs or first coordinates. And this is the set of outputs or second coordinates, right? The domain and the range.
Can you show me an example of the number of examples?
Yeah, that's actually what we're going to do next. Is that all right? So most of the domain and range questions that you're going to do in this class is going to be equations, okay? So as we look at the equations, they're going to ask you what the domain and the range is going to be. Just want to make this a little so that it's a lot more detail. Now, this is linear. You know this is linear because it's in the form y equals mx plus b. Hopefully you remember how to graph a line quickly. If you don't, it's not a loss because you can use your calculator to help you. You can use some of the strategies that we're going to use to graph the other things to also graph a line. When we graph things other than a line, I will require that you make a table. If it's a line, I'm not too picky about it because we know how to do a quick graph for a line. Hopefully you learned that in Algebra 1. Now your table can look like this, going across, or your table can look like this. Again, I'm not too picky on that. But anytime we graph something, it will say in the directions, show the table. What I don't want you to do is to look at your calculator and say, oh, there's my answer. Okay, I don't want you to do that. I want your graphs to be more specific. So as we look at our more specific graphs, let's take a look at how we can get a better estimate of where this graph will lie. You know that as you look at this, that the y-intercept is 2. And so on the y-axis, I would go up 2. And you see here that the slope is positive 1. So remember when we have a positive 1 slope, you go up 1 and over 1. So there's another dot, up 1 and over 1. There's another dot. And so this line is going to have lots and lots of, too close here, of dots, right? All of the things along this line are considered solutions, even the ones in between there, right? Those are all solutions. So we can have fraction answers and decimal answers, but the bottom line is that we have this line, and everything on this line is going to make this statement true. In other words, we could have 1/2, comma, 1.5, right? So we can have those decimal pieces and those fraction pieces as well. So this is the solution to that graph. And the domain for this line is all real numbers. Now you can write the words all real numbers, or you can use this fancy symbol that mathematicians use to indicate all real numbers. This is an R, kind of with an extra line behind it. It's kind of a fancy symbol that mathematicians use. But again, if you want to write all real numbers instead, that is the domain. Okay? Now, the range for this is also all real numbers. Now, just because it's all real numbers and all real numbers for this line doesn't mean it's all real numbers and all real numbers for every line. Okay, here's what I mean by that. If I have this line, and here's my graph, this is the graph y equals 2. The domain is still all real numbers, isn't it? But what's the range? The range is only 2. Excellent. You guys remember that. So just because it's linear doesn't mean that it's always all real numbers. There are some fancy ones.
So it's range, because, okay, so range is y, right?
Range is the set of y's.
It's like that, because it's going horizontal.
Correct. There's never another output other than 2. 2 is the only output for this equation that you'll ever have.
But for the domain, since it's going like left and right.
Correct. Correct. So it's any number left and any number right. So if we had another little picture that we wanted to take a look at, and this one was this way, at x equals 3, the domain would be 3. And it's only 3. And what would the range be? All real numbers. Okay, so your foundation seems to be pretty strong on that. So let's go ahead now and get into what we have to cover, which is a little different than what we've done so far. So foundations are strong. You will need graph paper. If you haven't purchased graph paper for your supplies, remember to do that. I don't want to spend a whole lot of time drawing these diagrams. Okay, so let's take a look at this one. Hopefully you recognize this as a parabola from Algebra 2. This particular parabola opens up. We know it opens up because this is positive. If A was negative, it would open down. Okay? Now, there's some that we're going to talk about this year that you probably didn't talk about in Algebra 2, and that is the ones that say x equals. Okay? This one is going to open to the right.
You still graph it, then you calculator or something like that.
Yeah. There is a way to do it. It's probably not worth all of the things that you have to do. What you can do is just graph it and turn your calculator sideways and reverse the point. That's a little easier than all the steps it would take to do that. And we'll talk about that when one comes up. But for this one, please graph this one in your calculator. Please graph this one in your calculator. If you don't remember how to do that, raise your hand, and I'll help you out. All right, so we used our calculator to help with our table, and we put this graph pretty accurately on our grid. Okay, so you will need to show enough information on the table to show me that you were accurate in getting that. But now we can look at this pretty easily, and we can see that the domain is going to go all the way over, and the range, the domain is going to go all real numbers again, isn't it? But the range is not going to be all real numbers in this case. What are the y values allowed to be? Bigger than 2. So it's going to be all values of x, or x such that x is greater than or equal to 2. In words, you would say all numbers bigger than and including 2.
So it wouldn't be like 2 to infinity?
Yeah, it would be 2 to infinity. If you wanted to use interval notation, did you use interval notation in Algebra 2?
Yeah.
Most of the calculus classes that you're going to be taking in college are going to use interval notation. And interval notation for this is negative infinity to infinity. That's the sideways 8. And interval notation for this one is 2 with a box because it stops at 2 but includes 2. And infinity. And remember, infinity always has those rounded pieces. You never square off infinity because you never get there. All right, so we talked a good bit about graphing, and we talked a good bit about range and domain. I want to just make sure we have a pretty decent understanding of that. So we're going to do some practice problems, and then we're going to continue to review for our test.